Dear Father in heaven, we are so thankful, Lord, for the time that we have here this afternoon to study and to go through a rather difficult study. We ask that you can enlighten our minds, give us understanding, and that you can bless the recording of this study, and that others can watch it and understand the purposes for us going into this depth into time. May your Holy Spirit teach us and guide us in the study is our prayer. In Jesus' name, amen. So good afternoon. This study here is going to be addressing some of the things that we looked at Friday night. And we were dealing with Ishmael and Isaac and the offering of Isaac as opposed to the offering of Ishmael, and what that would mean symbolically in relationship to the gospel. And in that study, we sort of, it degenerated to some degree into a study of the Molad, and not everybody knows what we were talking about. So this video is meant to help people to understand a little bit about the length of a month and what it means and how these are related to the calendar and to these spans of time that we have in prophetic periods. Now, the one that I want to look at here, maybe I will just zoom in a bit, that's a bit too much, is this study that we did with the 391 years. So this comes from the prophecy of Revelation 9, Josiah-Lich's prophecy. And this period of 391 years is from July 27th, 1449 to July 27th, 1840, is a particular type of period. That is, it's not just something random. It's an alignment of the solar year with the biblical year. Now, the biblical year works in these cycles called the Metonic cycle. And that is because the Bible uses years that use real months, that is, they're observed months of the moon. And a month is about 29 and a half days long. 12 months is going to be short of a full year by about 11 days. So there's 365 days in a year. And in a 12-month period, or a month, 12 months, where the moon is marking your months, you're going to have 354. So that's going to be 11 days less than a solar year. Now, what the Jews did then is every 2 or 3 years, they would add an extra month, a 13th month called Second Adar, to align the months or the year of this lunar months to the solar year. And they found out that there was this cycle they could use called the Metonic cycle, that they could just have their calendar repeat every 19 years. And they didn't really need to worry about observing the moon. And this, of course, became convenient when the Jews became spread out in other places and they weren't close to Jerusalem. And it might take, a couple of months to hear about what happened in Jerusalem in regard to observing the moon. So this was why they had this. And we sort of take for granted calendars and how they work, that we have this standardized calendar. But for ancient peoples, there was lots of different types of calendars. And there wasn't really any kind of standardization. Even when the Roman Empire introduced the Julian calendar, which later became modified to the Gregorian calendar under Pope Gregory. Julius Caesar's calendar wasn't really accepted by everyone. It was the official calendar, but people still had their other types of calendars that they would use. And I can at least relate to it in Canada, where we officially adopted metric, but nobody thinks about how much they weigh in metric. And I guess in the UK, people still talk about stones rather than kilos. And even though they made it law that you couldn't sell anything in a store in pounds, they eventually had to allow people to do that because people still think of things in pounds when you buy produce. You never think about how many kilos something is. So it's the same way. You can have a government impose a calendar upon you, but it doesn't mean that the populace is going to accept it, especially when calendars, there's all different kinds of them. There's local calendars that people have, there are religious calendars. There is just different countries or different cultures have different calendars that they use. And so this imposed Roman calendar was really a very artificial calendar. So the reality is that very few people used it. They still tended to use a lunar solar calendar, even in the time of Christ, even the time when Jerusalem was destroyed in 70 AD. And we know this because Josephus marks the date of the destruction of the temple as the 10th day of the 5th month, or as the 10th day of Av. And when he does that, and he has another name for Av, but he's using the Persian name or the Macedonian name, I guess, actually. So he's using a Macedonian calendar. And this is kind of something that sort of complicates things for a lot of theologians and scholars who are writing about the chronology of the period. Let's say, the 15th year of Tiberius that's mentioned in connection with the work of John the Baptist. The question is, what kind of calendar is being used? How do we know what the 15th year of Tiberius is? Is that the official type of calendar that's being used? We see the same thing in 457 BC, when it talks about the 7th year of Artaxerxes. Well, the Jews appear to be using a fall to fall calendar, where Artaxerxes would account his reign in a spring to spring calendar. And so these types of things confuse people. They make it quite difficult. Now, this movement ended up getting fairly deep into calendars. And with this 391 years, I just want to show you something before we go through my paper on the Molad, is that 391 years is 142,810 days. Now I have here written under this, it says it's more precisely 142,809 days and 22 hours. Now, of course, if we're marking out the day or the year based on whole days, the year would begin on a whole day. And so it would be 142,810 days. But when we start looking at that period astronomically, it's going to be basically a couple of hours less than that. So instead of 24 hours, 22 hours. And then we can represent 391 years divided by 12 as 32 years and 7 months, or 391 months. Now, as soon as I start throwing all those numbers at people, it becomes rather confusing. But since I'm dividing 391 years into 12, it would be natural that that period of time is going to be 391 months because there's 12 months in a year. So these types of things we don't think about much because we don't really do these types of calculations. Now, on the Gregorian calendar, does anybody know how long a month is? The average month.
It's about 30.6 or something. I can't remember exactly.
Well, they'll usually get 30.44, even though it's actually even more precise than that, because it's 30.4376129. So to be, very precise. But The Gregorian calendar has this average month, which we never experience because our months are either going to be 28, 29, 30, or 31 days long. So you're never going to have a month that's just a fraction, right? This would be the average of the different lengths of the months. Now, in the Jewish calendar, any sort of lunar calendar, a month is going to be either 30 days or 29. But it's not always going to be regular because a month isn't exactly 29 and a half days. It's slightly more. So we're going to look at that, and I'm going to try to go through this paper slowly. This paper that I wrote on the Molad interval. And in writing this paper, I tried to write it in the simplest way that I could. So it's going to show up on the screen here right away. But just because I wrote it what I thought was simple doesn't mean that it is. So it's entitled the Molad interval 76543 plus 1, and the Hebrew division of the day into 25,920 parts. So it's a rather cryptic title. So I'm going to read through this, and of course, if anyone has questions or comments, feel free to interject. It may be hard for the modern mind to grasp. Time is something that is fixed. An hour is a definite period of time. To the ancients, the hour varied in length based upon the length of the daytime or nighttime as it changed throughout the year. The relationships between the various cycles, days, months, years, etc., are measured by the arbitrary, though practical, divisions of the day into parts. The ancient Hebrews chose to divide the day into 25,920 parts, making the hour 1,080 of those parts. Why is this? This paper seeks to answer this question. So the question is, what is the Molad interval? The Hebrew word molad means birth and is a term applied to the birth of the moon each month. Specifically, it is a number derived from the mathematics used in calculating the Hebrew rabbinic calendar. So they had to calculate this calendar. And so they divided the day into a certain number of parts so that they could measure the month accurately. Because they didn't have decimal system, they only had fractions. The Molad moment refers to the average length of the rabbinic month, which is expressed as the Molad interval of 76543 plus 1 parts. The Molad interval can also be expressed as a period of 76543 plus 1 days, which is 25,920 months. Ancient Hebrew mathematics did not use a decimal system, thus time and its various parts were necessarily expressed as fractions. The number we wish to focus upon, and that is the result of these mathematical calculations, is 25,920. We will see why this number is significant. So does anybody not understand any of what I've written? Is it clear or not? So just to kind of explain a little bit, I'm going to go to this Molad calculator, and we're going to come back to this. But if I divided the day into 86,400 seconds, which is how we divide the day, we would then have to express the month as 20, which is 29.53094 days, as 2,551,443 seconds, right? Since this number represents seconds, that's how many seconds a month is. That's how long it is. So if we broke this down, we would find that it would be 29 days. But also it would be true that in a period of 2,551,443 days, we would have 86,400 months. And that would be a period of 72,000 lunar years and nearly 7,000 solar years. So this is what we're wanting to understand. Because if we're trying to use this calculator and applying it to prophetic periods, we need to know what it means. So hopefully people are able to follow this. I'm not sure. It took me a long time to understand it. I can't expect that everybody's just gonna pick it up like that. So let's look at this a bit more in detail. Our day is divided into hours, minutes, and seconds. The Hebrew division of the day is based upon a math that relates to the average length of the month. That is, the various parts are needed in order to express the length of the month in a way that is meaningful, at least to the ancient Hebrews. While we presently can describe the length of the month as 29.5306, so that's just a rounded up fraction, its expression has less utility than when it is described as a fraction, as we will see. Fractions and decimals are conceptually different, though decimals have some computational advantages that fractions do not. Fractions allow us to make connections that are not readily evident when using decimals. We will see why the Hebrew day is divided into 25,920 parts and hours, which are 1,080 parts each, instead of 1,440 minutes, or 24 hours and 60 minutes, or 24 hours of 60 minutes, with each minute being divided into seconds. The Hebrew name for each of these divisions is chelek, and the plural is halachim, which are equal to 3.5 seconds. Since there are 86,400 seconds in a day, if we divide this by 3 1/3, we arrive at 25,920 parts. Why this is the story we wish to unfold. So the Jews did not use seconds and minutes to divide their hours. They divided their hours into these chelek. So how many seconds are there in an hour?
1,000. No, sorry.
3,000
I'm thinking a day.
in an hour. So it'd just be,
How many seconds in an hour?
yeah, how many seconds in an hour?
Yeah, 3,600.
Yeah, so you just multiply 60 by 60, right? Now, the Jews have 1,080 parts in an hour, and that's just basically 3 1/3. So if you take 3,600 and you divide it by 3 1/3, you'll get 1,080. Right? And that's how many parts there are in a Hebrew day. So they're just dividing that. I mean, they're not using seconds, but if we were to take seconds and compare, it's a 3 1/3. That's the difference.
So
Yeah.
if they were saying what time of day is it, they would say, well, it's the 6th hour today and 500 parts.
No. So when they divided the day into chelek, this was for mathematical calculations only. It was not something they used in their day-to-day time. So they would just talk about the hour of the day. They weren't very specific in regard to dividing that hour in the practical everyday fashion. You would just know which hour of the day that you were in, because they didn't have clocks, right? Even minutes and seconds were more for astronomical calculations, not for keeping time originally. That is, people didn't keep track of time in the way that we do. It wouldn't be like 10 after 8. Until they had clocks, people wouldn't be that precise about timekeeping. They would know when it's noon, the noon hour, and they would know that they could divide the day into 12 of those hours. But they didn't think about dividing it into minutes and seconds in a practical way. They wouldn't say it's 8:30, because that would just be too precise. Does that make sense? Stephen, that makes sense? Okay, I think I got cut off for a second.
You're breaking up.
Okay, yeah, my internet was a little unstable there. It might even be more unstable. Can you hear me now? Okay, can you hear me now?
Yes.
Okay, yeah, so my internet showed up as a bit unstable. So does that make sense that people didn't use minutes and seconds in everyday life?
Yes.
Okay, until we had clocks. Now, this other thing dealing with months. So it says, in practical terms, if we wish to observe the start of each month, we will know that the average length of the month is between, we need to know that the average length of the month is between 29 and 30 days. That is, when you're going to count every month, you're going to realize it's 29 days and 30 days, which means that the average length is somewhere in between that. So, once you've counted 29 days for the month, that you would expect the new moon could appear shortly after sunset that evening. So on the 29th, you look out in the evening, the sun's going to set, and you would expect that you'll see the new moon, because the moon, it's at the end of the month, and you're going to expect that a new moon is going to arise. Now, if you don't see it, you know that it would show up the next day after that. So you don't actually have to go out on the 30th and observe the moon, because there can't be 31 days. So it's only on the 29th that you need to go out. So the first day of the month will follow either the 29th or the 30th day of the previous month. Now, if you kept doing this over time, you'd notice that there are more 30-day months than there are 29-day months. So what would that tell you if you know that there's more 30-day months than 29-day months?
That the day is above half, so it's above 29.5.
Yeah, so it's more than 29. The average month is going to be more than 29 and a half days long, right? If it was exactly 29 and a half days, then you would have an equal number of 30-day months and an equal number of 29-day months. But the fact that you get more 30-day months means that it's longer than 29 and a half. If you had counted and you found that there was more 29-day months than 30-day months, you would then know that the average month is shorter than 29 and a half. Now, it happens to be slightly longer than 29 and a half days. And so over time, people keeping track of these months would notice this. Now, this also relates to the need to add an extra month and how it relates to the seasons, how you keep the year aligned with the seasons. And this isn't readily evident, at least it wasn't to me when I first looked at it. Knowing how long the average month is, how does that help you with the year and knowing when you need to add an extra month? And this was part of the interesting thing for me personally, aside from the fact that how it relates to Bible prophecy. So it may not seem obvious to us, but knowing how many months contain 30 days compared to how many months have 29 days allows for calculations regarding the cycle of months and years. Again, we'll investigate this in more detail later. So this idea of observing the month, it was actually very straightforward for the average person in the past to just see when the month is, but we don't think this way. A month is something on a calendar, not something you observe. The Hebrew calendar is a lunisolar calendar or a lunar solar calendar. That is, it is based on the observation of both the lunar monthly cycle and the solar yearly cycle. It is hard not to notice that, and it is more obvious to those living far from the equator, that the cycle of the sun relates to the seasons. While the ancients were familiar with both the solstices and the equinoxes, which are commonly used to mark the passing of the seasons, it is the spring equinox that they chose to mark the return of the year. Of course, Since the year begins with the sighting of the first visible crescent, and this does not often align with the spring equinox, determining which observed month was to be the first in the year caused a problem. So we know we're going to have a month that's the first month in the year, but it doesn't just line up with the spring equinox. It's going to be in relationship to that. So you have to decide how you're going to do that. So the first month on the rabbinic calendar can begin as much as 2 weeks prior to the spring equinox or 2 weeks after. That is, they look at the full moon closest to the spring equinox for Passover, right? And then the new moon closest to the spring equinox for the start of the year. That makes sense. Maybe I'm not saying that right. But anyway, this was not the case in ancient times. So prior to marking the first month of the year, they had to wait for the sighting of the first visible crescent after the day of the spring equinox. Yeah, so with the modern Jewish calendar, Passover is always going to be after the spring equinox, but the beginning of the month can be 2 weeks earlier. But in the case of how they did it in biblical times, they would actually not have the year begin before the spring equinox. You'd have to wait until the spring equinox is past and then observe that month. So that change that happened hundreds of years after the time of Christ, that the rabbis decided to do it differently. And there's lots of political reasons why that was. One is it had to do with Easter. So for some reason, the Jews decided to align their year with the Christians. I'm not sure why. I've never been able to figure out why particularly they thought that was a good idea and why they would accept it, but they did. It could probably have something to do with the countries that they were living in. So at the end of the 12th month of the year, if the first crescent was sighted and the equinox had already passed, the next day would be Nisan or Abib 1, and a new year had begun. However, if the equinox had not passed, then a 13th month or second Adar being the 12th month, was added. Further, in counting the days for each year, they would find that some years are longer or shorter. That is, since they're using a lunar year based upon the moon, they might find even if it's a 12-month year, it might be 353 or 355 or 354 days long. Or if it was a leap year, it'd be 384 days plus or minus 1 day. The solar year from vernal equinox to vernal equinox would also vary in length, being either 365 or 366 days. So that is, if you're counting the vernal equinox at sunset, as the Jews did, you're going to be using whole days. And so you would realize that the year is somewhere between 365 and 366 days, because sometimes the year would be 365 and sometimes it would be 366. And that makes sense to people? Anybody having problems so far? I mean, I may have completely have lost you and nobody knows what I'm talking about, but can I have some affirmation that at least people are awake?
Yeah, I'm okay with that.
Okay,
Yeah,
Stephen.
I'm okay too.
Okay, Chris is. Okay, so the solar year from vernal equinox to vernal equinox can vary, right? So they could figure out, if they counted over enough years, you could figure out what the average year is. But the question is, did the ancient Hebrews understand the exact length of the solar year? We will see that if they understood the length of the month, then they must have understood the length of the year. However, since the Hebrew year greatly varies in length, it may not be obvious that they understood the exact length of the solar year. Our Gregorian calendar uses a simple cycle to align itself with the solar year, with a year of 365 days, with an extra day added every fourth year, unless the year is divisible by 100 and not divisible by 400. So the Julian was actually just simpler. Every fourth year, you add an extra day. Ours, we have some years that we don't. Like on the centuries, and we do if it's 400 or 800 or 1200 or etc. The year 2000, we did add a leap year, even though it was a century. But anyway, the Gregorian calendar really has quite a simple cycle compared to something like the Hebrew calendar. Now, we're going to look at the Metonic cycle. It was noticed over time that a leap year, or embolism as they called it, would occur every 2 or 3 years. These embolismic years also occurred in a particular pattern or cycle, and these cycles were determined to occur every 19 years and are known as the Metonic cycles, being named after the Greek mathematician that first described them. Specifically, it was noticed that in every period of 19 years, there were 12 years of 12 months and 7 years of 13 months. In total, a Metonic cycle would then have 235 months. That is, if you take 12 by 12, you get 144, and 7 by 13 is 91. It should be obvious that the observation of longer cycles leads to a more precise estimation or measurement of the average length of the month, or as it is referred to by the Hebrews, the Molad moment. To know the length of the month, then, we simply need to know the number of days in a Metonic cycle and divide by the number of months. The number of days in a Metonic cycle was determined to be 6,940 days, producing a month of 29 days, 12 hours, 45 minutes, and 57 and a half seconds. So if you just take the number of days and you divide it by the number of months, and you figure it out in hours, minutes, and seconds, that's how long the month would be. Now, this is very close to the actual length of the month, which is actually 29 days, 12 hours, 44 minutes, and 2 3/4 seconds. While 19 solar years are very close to being 69,440 days, or 6,940 days, they are short by 9 hours, 33 minutes, and 42 and a half seconds. So when we're dealing with the actual number of days and solar years in relationship to the months, that is 235 lunations are 6,939 days, 16 hours, 30 minutes, and 43 and a half seconds. So you can see that there's a difference, which is precisely accepted definition of 235 synodic months that equal 6,939.688 days. So when you're trying to line up years and days and months, they don't line up equally. For the ancients, the precise measurement of these cycles was derived by the examination of longer cycles, where whole days, months, and years align more closely. So instead of looking at the fractions as much, they just looked at these longer periods, but then they could take these longer periods and translate them into fractions rather than decimals. So this idea of the Metonic cycle, which is this 19-year cycle, you can see that it's pretty close. If you just take 490 days and you divide it by 19 years, that you're going to get this math that shows that it doesn't line up precisely. Okay? So how do we deal with that? How do we address that? The way that they addressed it was how they divided the day. Now, there's this thing called the Molad interval, as we've talked about. Now, there's some uncertainty about how the Molad interval was derived. A period of 765,433 days, right, or written as 765,432 plus 1, is equal to 25,920 months. As noted earlier, this relates directly to the length of the month, which is 765,432 plus 1 helicene, each helic being 25,920th part of a day. This allows us to meaningfully express the fractional part of the length of the month as 13,753 over 25,920 parts. So we know that a month is 29 days and a fraction, but that fraction is very specific in the Hebrew calendar. Because they divide the day into 25,920 parts, they can represent that fraction as 13,753 over 25,920. So that is, if we divide the month into 765,433 parts by the parts of the day, 25,920, it equals 29.530594 days. That's how long a month is in the Molad calculation. We can multiply the remainder of 530594 by 25,920, and what you get is this, the numerator, which is 13753 parts. This can be reduced to 29 days, 12 hours, and 793 parts. That is, 12 hours is half of 25,920, or 12,196 parts. 793 parts that remain would be 793 times 3 1/3 seconds, or 2,643 1/3 seconds. This can be reduced to 44 minutes. 793 times 3.333, that's how we do it on a calculator to deal with 3 1/3. And that would be with a third, so it's 44 minutes and 3 1/3 seconds remaining. That's what 793 parts mean. The Molad derived month then is 29,005.30594 days, which is more practically expressed as 29 days, 12 hours, 44 minutes, and 3 1/3 seconds. This is a very precise measurement when we consider that they did not have the modern scientific technology that we rely on. How did they arrive at this number? Now, is anybody not able to understand what I did with this math? Is this kind of cryptic to people? People have to be honest. Because I can break this down if people are having trouble with it.
Yeah, my mind is really spinning, but because I'm
Okay.
not good at math at all, but eventually I'll get it.
Okay, so I'll try to explain it just in a simple way. We know that a month is 29 and a half days long, but slightly more, right? So Angela, I'll try to use you as an example.
Yes, yes.
Through this. Okay. Because other people watching may have the same problem. So you having a problem is helpful. So, but we know it's not exactly that. It's going to be slightly more. Now, what the Jews did is they had to use fractions, right? So they didn't use decimals. And so just like if you want to feed a pie to a lot of people, you're going to have to cut it up into a number of pieces, right?
Of course.
Right. So let's say there's 9 people, you'd have to cut the pie up into 9 pieces. Now you might be able to with a few different pizzas, if you had a pizza pie, and you're going to cut it up. The more people you have, the more you're going to have to figure out how many parts you're going to have to cut that pie into. So there's lots of different ways it can be done as far as dividing the day. But the Jews chose to divide the day in a way that related to a larger cycle. So when they divided the day into 25,920 parts, what this allowed for was a very precise fraction that when we convert it into a decimal is very close to the modern calculation and actually is very, very close. So 1 in a millionth accurate. So because the month has actually changed over time. So our month is slightly shorter than the month was back in the time that the Babylonians did it. When they did it, the Babylonians and the Jews, they actually were exactly on within 6 decimal points, even though they weren't using decimals, they were just using fractions. And the way they did this is with this Molad measurement. By dividing the day into this many parts, they could then express the fraction of the month in a very precise way. So if you were going to cut the day into 2 12-hour periods, the daytime would be 12,096 parts, and the nighttime would be also 12,096 parts. And if the month was exactly 29.5 days long, then obviously you wouldn't need all these divisions if you're going to figure out the month. But you would see that if the month is 29 and 13,075 parts over 25,920 parts, the difference is 973 parts. So that's how much more it's longer than 12 hours. So the month is 29 days, 12 hours, and 44 minutes and 3 1/3 seconds, because those 793 parts can be converted into hour, minutes, and seconds. Does that make more sense?
Somewhat.
Yeah.
Just all these numbers, my head starts swimming.
Yeah. Okay, well, the numbers aren't that important. Just the fact that you know that the month is not exactly 29 and a half days, but it's a little bit more. And that little bit more is just 44 minutes and 3 1/3 seconds. That's how accurate their measurement was, or their calculation of how long the average month was. And that is so precise, it was exactly as precise as if we had 6 decimal places. So that's how precise their measurement was 500 years before the time of Christ. So it's very, very accurate. Now, but the question is, how did they come up with this number? How did they come up with this precise measurement? Now, before we answer this question, we want to look at the practical application, at least in part. Now, to do this, I'm just going to bring you to this calculator that we have, the Molad calculator, and try to show you what this means. So if I divide the day into 5,920 parts, this calculator will tell me that a month is 765,433 parts. So if I converted that into a fraction, it would be 29.530954 days. But this would also tell me something which we wouldn't naturally think of, but is obvious once that you think of it. That means if I had a period of 765,433 days, that would be 25,920 months. Because if whatever I divide the day into, that means the month will be expressed in on the number of parts, and whatever those parts are, I can just convert them to days to give me the number of months that I have divided the day into. I mean, it's kind of a long sentence. So just to look at this more closely. So let's say I divide the day into 24 parts, 24 hours in a day. But how long would the month be, according to this? Angela, if you can look at this. And how long is the month if I divide it into 24 parts and I express the month as how many hours it is? So it's 29 days and a half. How many hours is that, according to this chart here?
I'm trying to grasp what all this is.
Well, you see here, I divided it into,
24 parts.
and the month
in-
is then,
It says a month 29.530594.
okay, that's in our thing, but how many hours is it then? In 29 and a half days, how many hours are there?
29 times 24 hours. I mean, if I'm calculating the normal way.
Exactly. So that's going to be 709 hours. You see that there?
Yeah.
Okay. So that's pretty simple. If I'm only measuring the month in hours, I'm not using days, I'm just using the parts of the day, 24 hours, it's going to be 709 hours long. Now, of course, that's not going to be as accurate because I'm only using hours. And the more detailed I divide the day, the more accurately I can represent how long the month is. But if I'm just using hours, I'd have to say it's 29 days and 12 hours. Well, if you take 29 and you multiply it by 24, and then you add these extra 12 hours, well, it's going to actually, I think we're adding almost 13 hours there. I think it's rounding it up. We're going to end up with roughly 7,009 parts. But that means that in 709 days, I would have 24 months. And that's not something that we would normally think of, but it's something that the ancients understood, that however you divided the day, what they were really doing is they say, if I calculated how many days it took 24 months to happen, right? So I counted 24 months. That means if I divided the day into 24 parts, then the month would be this many parts long, right? So let's look at it this way. They had decided to divide the day into 25,920 parts, as we noticed. But really what they had done is they had looked at a period of 25,920 months. And from that, they based this cycle on a calculation that in that many months, it would take 765,433 days. And that meant that if they divided the day into the same number that they had of months, that they could express the length of the month as 765,433 parts. Now, the interesting thing when you look at this, and we're going to address this a bit further, is that this is 2,160 lunar years. Lunar years are just 12 months. So a year of 12 months, 12 lunar months, where we have a year of 12 months, but our months are longer, right? By almost a day longer than the average lunar month. So you can see 2,160 lunar years is 2,095 solar years. So this idea here became extremely useful in understanding these various cycles. So we're going to just deal with this here. Go back. So that's the Molad interval. And the thing that they could figure out is in 25,920 months. Oh, that's the other part I have to show you. So I didn't show you that part. So let's go back here. So in this number of months, what it was useful for them is they could know that in 2,095 years, that you're going to have 13,753 months of 30 days and 12,167 months of 29 days. So this was really useful. They could see the ratio of 30-day months with the ratio of 29-day months. And this also helped them then to decide how often you're going to have months of 30 and 29 days and where you would place those months. So this is part of their calculation of their calendar. It also helped them to calculate the leap year as well. So let's look at here the precession of the equinoxes. Okay, so one thing we know about the ancients is that they observed the precession of the sun, moon, and planets as they move through the constellations of the zodiac. So procession there is that they proceed or they move in which direction does the sun, the moon, and the stars, the planets, which way do they move in relationship to the stars when we see them moving? You know, every day they're going to move a little bit. Which direction do they move? The sun, we know which direction it moves. It moves from east to west, right? So we see the sun, we see the moon, they rise, and the stars themselves. You know, Venus is going to rise, you know, in the east, and it's going to set in the west. Any of the stars will. They're not going to rise in the west and set in the east. So they proceed through the zodiac, and throughout the year, they move along through the different constellations of the zodiac. So in the spring, the sun is in Aries. That's when you have the beginning of the Jewish year. So you're always going to have these different constellations that the sun and the moon are going to rise and set in, and of course the planets as well. Now, one thing that they started to notice, though, that the thing called the equinox, when you have the equinox occurs, it has to do with where the sun rises every year, and that there's a precession that occurs with the equinoxes. That is, if you look at the equinox and where the sun is rising on the day of the equinox, or setting, if you're using the sunset, that it's going to, over a period of 72 years, move 1 degree in reverse. And so this precession of the equinoxes means that in 36 degrees, 360 degrees of that we see of the entire horizon of the sky, you would just take 72 times 360, and you would find that they would come back to the beginning of this precession every 25,920 years. So this was the thing that struck me, because why would the Hebrews divide their day into 25,920 parts? Would that be possibly because they understood the precession of the equinoxes, and that they chose this as a convenient number, in that they were looking for patterns in the universe? And since they had this other number already, that they decided to do this. So, and then if once they did this, would this have led them to the precise measurement of the length of the month by providing this division of the day? And this is quite profound. It's not necessarily the easiest thing to understand. It took time for me to get my mind around it. But we have this cycle, the precession of the equinoxes, and we're going to come back to this now.
But there's other civilizations apart from the Hebrews that understood this time period.
Yes. Yeah, it was actually well known in ancient astronomy. Yeah, so, you know, and I've been reading lots about these different calendars. So they did understand this precession of the equinoxes, not just the Hebrews, but not everyone chose to divide the day into 25,920 parts, right? So there's different ways in which people dealt with this math. In India, they developed a much better math, really, than in a lot of ways than what you had in Babylon, but nonetheless, they still had ways of doing these calculations. People were very concerned with calculating the calendars, right? Trying to predict when exactly these cycles would repeat.
So
Yeah.
how this year precession, if it's starting now, the equinox is in Aries in the spring. So eventually it's going to go to what, Pisces then?
Yeah,
And then
yeah, it's gonna.
Aquarius,
Mhm.
Aquarius, and then was it Capricorn? Will eventually just go right through all the way through the.
Exactly.
Okay.
Yeah. So right now our equinox happens in the spring, which, well, it always does, But in the spring right now, it's going to be in Aries. It's going to be in that constellation. But as time moves on, it's going to continue moving backwards through the constellations, opposite to the way that they process. Their procession and their precession are in opposite directions. And so they could calculate that this is going to take 25,920 years to go through the whole cycle. Now, scientists now will tell you, of course, that this period of time is changing. That is, but back then, when they measured it, it was 25,920 years. And that's the number they chose to divide the day into. Now, just addressing the length of the year a little bit, they define the length of the year using this metonic cycle. It is knowing how many months happened in 19 years and knowing how long the month was could then tell them how long a year is. Now, this is a rather complicated problem, so I don't really want to go into it too much. But I do want to show you something. This is from a book, Calendrical Calculations. It's a math calendar book for computers people. And one of the things you can see is that there's lots of different lengths of the year. Different Egyptian length of the year is 365 days, the Mayans 365, that's the Hab cycle. They have an implicit cycle, which is 365.24204. And they also have a length of the month based upon that. The Julian, Coptic, Ethiopic has 365 and a quarter days. The Hebrew, 365.24682. The Easter calculation for the Orthodox is 365 and a quarter. The Islamic doesn't particularly have a length of the year because they just have 12 months, and that can vary. The Hindu calendar, the different types of Hindu calendars, Tibetan calendar, Gregorian, etc. Now, one of the things that's interesting, though, is at the bottom. If you look in the year 1000 BC, the year was longer than it is now. Not very much, really just a few seconds, parts of seconds, just a very, very small fraction longer than it is now. Now, you'll see here that in the year zero, so there is no year zero except in astronomy. But notice the length of the month is 29.530595. And it keeps getting shorter. So if you want to go to about the time it was 29,000 or 29.530594, you would be about the year 300 BC or so. And that's around the time that the Jews and the Babylonians calculated the length of the month as 29,000, or not 29.530594. That is, their measurement was exactly within a millionth. Well, so that means it was exact to a millionth of a day, millionth part of a day, which is pretty accurate. But you're going to see that, the year's going to keep getting shorter, and the months themselves will also keep getting shorter. So it's just an interesting point, how accurate they were. So I want to get into the real body of this. And we have this Molad interval and this 25,920 parts of a day. So I don't want people to get really too caught up in all these really fine details. But what we can say is that this period of 765,432 plus 1 days is 2,095 years and 8 months. So that's how long it is. So it's pretty precise. But if we looked at lunar years, we would see that there's, as we pointed out earlier, that this many months or this many days would be exactly 2,160 lunar years. Now, what's the significance of 2160? This I'm going to draw as well.
6 times 6 times 60.
Okay, so it's 6 times 6 times 60. That is, we know 6 times 6 times 6 is 216. And this to me is, I want to add diagrams to this. And one of the diagrams I need to try to do is this. So this is a circle, okay? I think looks pretty circular. Now, think of this as the precession of the equinoxes. And so what we're going to do is we're going to divide this into pieces that are roughly equal. My lines don't go in the center. Just imagine those lines are all crossing in the center. If this is 25,920 years that are represented, as the equinox precess through the 12 signs of the zodiac, they represent a period of 2,160 years. Does that make sense?
Yes.
Okay. Now, this, of course, is not lunar years, but it's just a simple fact that we can relate this to this period of 25,000. If this was,
It is lunar years.
what's that? No,
That's
no, I'm not using lunar years. I'm using lunar. This is actually actual years. Because lunar years, this is where I kind of confused you, I think. So because lunar years are actually shorter than actual years. Because this is actually solar years, right? So if I
okay.
divide the solar years, I'm going to get this pattern. Now, the fact is, though, that 25,920 months equals 2,160 lunar years, right?
Yes.
But these are solar years.
Okay.
This is, I'm not going to have time today to really get into the nitty gritty of this. But what we can say is that there's a relationship between this cycle and if we were going to divide this into 2 months, we could divide it into 25,920 of our months. Does that make sense? Gregorian months.
Mm-hmm.
Okay, so there's this relationship between the lunar month and the Gregorian months. So this is 30 degrees because 12 times 30 is 360, right? So each one of these signs of the zodiac take up 30 degrees of the sky. Does that make sense?
Yeah.
So this key, though, understanding, when I saw this with the lunar calendar, I then understood that we can call this is called the great year, the zodiacal precession of the equinoxes, as opposed to our regular year. So can we see that to the ancients, this precession of the equinoxes suggests that the great year, since it's 25,920 years, and we can then look at 12 divisions of that great year as being 2,160 years, these solar years. But that we also understood that this number of months equaled this many lunar years, that they would then choose to divide the day into this many parts in order to do the calculation of how long the month is. That is, once they knew that we could take this many years and it would have this many months in it, it suggested to them that we could divide the day into this many parts so that the month, so this many months is 7, 6, 5, 4, 3, 2 plus 1 days. That means if I divide the day into this many parts, that the month is going to be this many parts long. they thought that way. We generally don't. We're not that bright. At least I'm not. That's why it took me quite a while to figure out what they were actually doing. And I don't think other people notice this. That is, I haven't been able to find, I know there are people who know that the precession of the equinoxes is 25,920 days. And they might even notice
Years.
I mean, they might even know that the Babylonians divided the day into this many parts, and the Jews did. But they don't put the two together. And generally, people who see this precession of the equinoxes, the vast majority of them have no idea how many parts are in a Hebrew day. And those that know how many parts are in a Hebrew day aren't generally interested in the precession of the equinoxes. So for some reason, these two haven't come together as the reason they divided the day into this many parts. Does that make sense, what I'm trying to claim here? I'm making a claim that the reason they divided the day into this number of parts was because they understood the precession of the equinoxes. And it allowed them to measure then the length of the day in a way, divide the day in a way that related to the length of the month in a very precise way, but also related to the great year, to this precession of the equinoxes. To them, they would see that this has design. Now, in my paper, I go into a little more detail regarding the Molad interval and the Metonic cycle, but I want to skip through some of this. I talk about the great year here. I sort of summed it up, and people can read through the paper. Anybody who's watching this video, it's on my academia.edu site. You could also write me, theodorejamesturner@gmail.com. But I'm just going to go through this and say some conclusions. I'm going to read these paragraphs here. I'll read them slowly, and if you're still awake and you can concentrate, see if this makes sense. What we can conclude is that the relationship between these periods, parts of the day, the lengths of the months, the lengths of the year, the length of the Metonic cycle, the length of the Molad interval, and the great cycle of the precession of the equinoxes are all interrelated. The question still remains, how did they arrive at the number 25,920? Was this based upon the great cycle, or was it merely a convenient number for calculating the length of the month? I think it's too much of a coincidence to say that this was just merely something that resulted from their math. I would say that they chose this to put this in their math because they had already calculated the precession of the equinoxes. If the ancient Hebrews had simply tallied the number of days in relation to the number of months over a long period of time, they would have come to an approximation of the length of the month. It could have been merely fortuitous that they happened to recognize that 2,160 lunar years came to 765,432 plus 1 days. They would not have had to count that many years. They would simply need to calculate this from the approximation of the month. They would have looked for order in the universe. That precession seemed to be 1 degree for every 72 years. 6 times 6 times 2 years. That this produced 25,920 years for the great year. That 2,160 lunar years was 25,920 months. And that this was also 765,432 plus 1 days seemed either a happy coincidence or design. Further, they could readily see that 765,432 plus 1 days were 25,920 months. And if the length of the month could be expressed as 765,432 plus 1 parts, with the day divided into 25,920 parts. Of course, we cannot know for certain that this was how their understanding came together. So in order to come to that number, they had to have come across it either by coincidence or or in some way that it was just like pure luck that they came upon this number that happened to be the number of years. Now, in the paper, I also deal with a calculation. So I'm going to finish off with this idea that I don't think I express well in the paper. I have to do some rewriting of this paper. Let me go here. So I'm going to go back to the whiteboard. Now, if you're going to convert pounds into US dollars, Stephen, do you know what the conversion rate is? Or euros or anything?
Oh, sterlings, I think it's £1 pound, $1, or sorry, £1 equals about $1.37 or something.
Yeah, so you're going to have this conversion rate, right? To convert pounds into dollars. And normally you'll have, if you're having a conversion rate, you will be converting the smaller amount into the larger quantity, right? So American dollars are larger than Canadian dollars. So if I want to convert a Canadian dollar into American dollars, I have to multiply it by 1 point something, right?
Mm-hmm.
Now, I'm not sure if I got the exact number, but a Gregorian month is 30.43. I think it's 76129. I could be wrong. It could be 67. I always get those mixed up. And so that's a Gregorian month, and a lunar month is 29.530587 or 588. Now there's a conversion ratio. If I want to convert this into this, I would have to multiply it by 1.0307. And if I multiply this, I will roughly get this, not exactly to this many decimal points, because this is actually not, is more 6 something or whatever. But this is how I convert a month into a year. Now, if I understand how many cycles, metonic cycles are going to occur, and this is what I have to put in my paper because I failed to neglect this point. How many metonic cycles are in this cycle of this many days? So there is a certain number. I just can't remember what it is, and it's not quite exact, but
I can work it out.
yeah. Well, it's going to be 2,095 years divided by 19, roughly 2,095 years plus 8 months.
Well, it's 765,433 divided by, is it 6940?
Yeah, well, it's 6,939.688.
Okay, 693. 69, sorry, what was it? 39?
Yeah, so it's 6,939.668. That's how long a metonic cycle is.
Okay, it's 110.297889.
Yeah, 110. And there's going to be so many months. Now, in doing this, what they can figure out is they can figure out the conversion rate between a solar year and a lunar year. So a lunar year is 357. We'll just use this rounded off, 0.37. If you multiply this by this number, what number do you get?
Well, it should be 365.24 something.
Yeah, something like that. But we just say this much roughly. Okay, so you're going to end up with this conversion rate, which is this. Now, I can do the same thing if I take 2095. Let me see, how do I do this? Never mind, I got to think this through. Well, what happens if I take this one and I multiply it by this number? What do I get? I don't,
2095 times
1.0307. I don't think that will work out. Because I'm going backwards the wrong way.
it's 2159.
Okay, so it does work out. So that's going to work out to, if I can multiply this by this, I'll get 2160 roughly, right?
Mhm.
Because this is 9 and it's a decimal. Okay. So what this tells me though is that there's a relationship between this cycle and the lunar cycle that they could figure out how long a year is. Does that make sense? And that they would understand that this number here, which is a lunar cycle, would be equal to this many years, and this many years times 12. Yeah, so I would have to convert it again. They'd have to do another conversion, but they could figure out that there's more than 12 of these cycles. I can represent it this way, but they would know that they could do the math to figure out that 25,920 years is, because they can know the length of the year, divided by 12 equals 2,160 solar years. So I didn't do a very good job of explaining this, but they could figure this out because they could understand the relationship between the solar year and the lunar year. And my suggestion was, when they figured out that this many months was this many years, they could, and this many years, it allowed them to do this calculation, which I didn't do. But does that make sense? And probably to Stephen it does. So this would tell us that the ancient Hebrews understood how long a year was. And if one is, they could count it. I mean, they could count every year how many days it was from equinox, spring equinox to spring equinox. And they could figure it was roughly 265 and a quarter days. But they also had this calculation for the month. Now, we have this, I don't know if I can explain it. What does this mean then? If they could do this, what does this mean for the prophetic periods? What is it about the prophetic periods, which I haven't applied here yet? But what could we suggest that this does in our understanding of the prophetic periods? Here's another thing. If there is 12 months in a lunar year of 354 days, there's also 12 months in a prophetic year of 360, correct? And that the difference between a lunar year and a prophetic year is a certain conversion. Does that make sense to people, what I just said?
Yeah, of course.
Yeah, I mean, it's pretty obvious that we can do that. Now, one of the things I've been working out that thought I would have time to today, but I don't, is to look at, because we looked at in our study on the week of Christ, we looked at lunar years, or not lunar years, biblical years and prophetic years and solar years, but we never looked at lunar years, correct?
In the calendar converter.
Yeah, not just in the calendar converter, but I'm saying in our calculations of what 490 years is. We looked at 490 prophetic years, we looked at 490 biblical years and 490 solar years. And we sort of hinted at it in some of my studies at the lunar years. I did actually kind of look at it, but I didn't fully understand what it was I was looking for. That is, there is a relationship between these prophetic periods in a way that I never saw before. Well, that's not true, because if I go to this chart of Josiah Litch's prophecy, which I showed at the beginning, in this prophecy chart, we're relating lunar years and solar years together, and also prophetic years. That is, we have the Islamic calendar, which has, in this period of 391 years, is exactly 430 or 403 Islamic years or lunar years. And so I don't have time to go through this, but as I started to look at this, I realized I had things under my nose that I missed. There was things I missed. That is, I didn't fully understand how this relates to the other prophetic periods. That is, we divided this 391 years into 12 parts because in 11,900 days, while the solar year is 32.53 years, there's 33.583 lunar years that occur at the same time. That is, the Islamic calendar in a period of 32 years and 7 months, where we have 32 years and 7 months, they go through 33 years and 7 months. They get a whole extra year. So you can live a lot longer if you're Islamic than if you're not. Well, it's the same number of days, so, but a different number of years because their year is shorter. And their month is a lunar month, not a month as such as ours. So the fact that I divided that thing, that great year, into 12 parts, right? This 12 divisions of the zodiac. Notice I can do that with this 391 years. And in that period, each of these 12s, obviously there's 391 months, but there's also 403 lunar months in the same time that we have 391 Gregorian months. And we can convert those with that math of 1.0307. Now that makes sense to you, right, Stephen?
Mm-hmm.
Okay.
Yes.
How about Iran, if he's awake? Does that make sense?
I'll have to look at that later. I'm not actually seeing the screen right now.
That's what? It's clearer?
No, I just said I'll have to look at it later.
Oh, okay.
I can't see the screen.
Oh, okay. Chris? I don't think Chris is.
The biggest part for me is to think more about these conversion factors and converting from one to another.
Yeah. So I'm going to actually work on my conversion calculator to calculate between not just lunar years and solar years, but also prophetic years. And then we can start to notice some things that God has put in his prophetic periods, which we have used as solar years. He has put an interlocking system or numbering that relates to these cycles that we see in nature. And we should have seen this with the 391 years of Josiah Litch's prophecy. Well, I mean, we did see it, but we just thought it was something unique to this prophetic period, but that it actually exists in the other prophetic periods as well, because the relationship between solar years and lunar years, between our calendar and being divided into 12 months and other calendars being divided into 12 months also exists. Now, this gives us some keys or analytical tools to look at Bible prophecy and see things about Bible prophecy that we never saw before. But the problem that I'm having is it's not It's not readily evident. It's not as clear as I would like it to be so that people can see it. Right? So I'm trying to work out, how do I explain this so that we can look at it clearly? And it becomes very profound because we started looking at it on Friday in relation to the 215 years, but we also saw it related to a cycle of 217 years. That is, if we took the prophetic mirror, of 2,604 years. So I'll just do this quickly. Try to find one. Okay. Let's go again. So here we have this prophetic mirror going from 742 to 1863. But if we took 2,604, we divide it by 12, we get 217 years. But the question is, and we know that that's a symbol of midnight, July 27th or July 21st. But there are some other things that we need to notice about this, and that it also relates to the period of 215 years. So that's what I want to examine. Any questions before we close with prayer? Was this helpful?
Yes.
Okay. It was helpful for me because I need to present things before I write them down. When I write them down, I mean, it's helpful as well. Sometimes I see problems when I present that I don't see just when I write. So I'm going to have to rewrite the paper to be clearer and to bring in some illustrations, I think. And I've tried to work out what illustrations I need to do. That's part of the problem, because I know illustrations help people. Well, let's close with prayer. Dear Father in heaven, we are so thankful for this afternoon, for this study, which still is just the beginning of a study that we don't fully understand yet. So we ask for your Holy Spirit to continue to help us to read through the paper on our own, to try to understand it, and help me, Lord, to figure out ways to present it more clearly. Be with us through the rest of this day, throughout this week, in our morning studies, and may your angels watch over and protect us. We pray in Jesus' name. Amen.